The last thing that we want to consider is looking at error and looking at rounding, and they will go hand in hand. When you're taking measurements, the very last decimal place or the very last significant digit that you have is going to be assumed to be rounded. So if you think about making a measurement, and let's say that you measure something to be 12.2 centimeters long. Well, that 0.2, you probably had to round just a little bit. So you looked at your ruler and you saw that the end of the whatever you're measuring was close to the 2 millimeter line, but it wasn't exactly there. But it was closer to the 2 millimeter line than it was to the 3 or to the 1. And so thinking about this is that error is happening in that very last significant digit whenever you're measuring something. So if we're trying to look at possible errors, that last significant digit is likely to be somewhat of that last significant digit is going to be from some level of estimation or rounding off. So the possible error is at most 1/2 of the unit in the last significant place value. I know that's a little confusing of a way to word that, but I think when I show you how to work on it, it'll be a little bit easier. So if we look at example 5, we know that this measurement was given as 156.2 feet, which means we're confident about the 156, but that 0.2 probably came from some level of rounding or estimation. So the furthest that could have been to round to 0.2 is going to be 0.15. The largest that could have been to round to 0.2 is 0.25. And if you think about this, I'm going to try to draw a ruler. So we know 156 is here, and 157 would be there. And then you have the little marks in between there. So we're rounding it to be this 156.2. And if you think on that number line, where would we have rounded to that? Just a little bit to the right and a little bit to the left. If it had been less than 0.15, we would have rounded down to 1. And if it had been more than 0.25, we would have rounded up to 3. So how do we easily get this answer without having to think about our ruler every time? You'll put the half, the 5, in the next decimal place. So what do I mean by that? 156.2. Well, the next decimal place is there right after the 2. And so you'll subtract 0.05. Okay, I'm just putting a 5 in that next decimal, so I need it to be in the second decimal. And you'll add 0.05. And that's going to give you this range of values that the actual length could be. It's going to give you the values that you would have rounded to 156.2. And so when I subtract that, I get 156.15. When I add that, I get 156.25. So you figure out where your last decimal place is, and then you put a 5 in the next one, zeros in front. You subtract that, you add that, and that's going to get the range of values that you would have rounded to whatever your answer is. Now, when you're just trying to round numbers, the procedure here is first look at the number of significant digits and then go to the next place. So that next decimal place or that next significant digit. If that digit is less than 5, then you just leave the last digit that was significant and we're done. If the digit in that next place was greater than or equal to 5, then you're going to increase the final digit and your significant digits by 1. So let's take a look at example 5. We have 70,360 and we want 3 significant digits. So I'm going to count 703 and that would give me my 3 significant digits. So how do I round? I look at the very next number, the 6, and since that 6 is greater than or equal to 5, then I need to round my final significant digit up, and then everything else will become a 0. So 70,360 for 3 significant digits would be 70,400. So it's probably a little bit different of a way that you thought about rounding than you did when you were in school. Let's do one more. We have 39.72 to 2 significant digits. So we're going to have the first 2 as our significant digits. To determine how this rounds, we look at the next digit, which in this case is the 7. That 7 is greater than 5, so we will have to round our last digit. 39, since it's ending in 9, you have to think of what number comes next, and that would be 40. So here, the 40 would be our answer. And so that we know that this 40, the 0, is actually significant in this case, you can put the little bar over it so that you know that it's significant. But we don't want to put any decimals here, because if we put a decimal and an additional 0, then that would make that be 3 significant digits, and we don't want that. So you could leave 40 and you could put the bar over it. If you left the bar, then somebody might think that it was only 1 significant digit, but for your calculation, you would know that you used the appropriate number of significant digits.